Do we need to do that assignment or no?
So, I kind of, not sure. That's what I was trying to think of, because the hour you had yesterday should have been enough time to finish all of it. I think there's 16 questions total. It's one of those circuit worksheets that one answer leads to the other, so they're kind of self-correcting. I'm wondering if it'd be a good idea to have you do it, but I'm not so worried about like, it doesn't need to be done quickly. So it's specifically on chain rule, which is the hardest parts of the derivatives. And I don't know how to say it other than what would be a good compromise? Because I don't want to add to your workload.
Why don't we just do like 3 problems here in class right now and then call it done?
No, because I want to start teaching the next section. And this should go quick enough that we will be done with time for you working here on this section. Monday and Tuesday are dedicated for section 6, which shouldn't need a full 2 days, but we're still dedicated to that. Wednesday's review. Thursday's the test. Did they send home a letter about the 1 day off every unit or something like that? I don't even know if I'm supposed to say anything about it yet. So we're supposed to take 1 day where there's not any new instruction per unit. So the reason for doing that is for the students who can't come before or after school to make things up, like to retake tests. That would be the day that they could retake stuff. So my plan is we're essentially always going to do that on review day. Because Calc, we have so much stuff to fit in that if we took off an extra day every time, we would be done like right as the AP test is going, and we don't want that. So I'm most likely going to make the one non-instruction day to be like the review days. Because if somebody wants to retake a prior test, that would be a good day for them to do it if they can't come before every school. Now, I know for a lot of you that's not necessarily an issue, because a lot of you have been making things up before and after school already. This is pretty much specifically dedicated to the people who aren't able to get a ride. And then that way, it kind of guarantees we'll always have a review date. And or you'll always have time to make it up if you need to. So that's kind of our plan. That's what next Wednesday is going to be dedicated for. It's for anybody that needs to retake or do corrections on the test we just had that can't come in on their own. So we'll always have the review date. The worksheet from yesterday, why don't we just kind of make it optional? I'm not so worried about you actually turning it in, right? Like the whole idea from yesterday was, I think a lot of you don't remember details from derivatives. And it's going to be really important that you do. So if you're a person who forgot a lot of things, certainly why don't you just try some of the questions on that worksheet, do as much as you feel you need to. I don't necessarily like setting it up that way because I know people who are being lazy are just automatically not going to do it. And they very well might be the people who need to do it the most. But I also don't want to add to your workload outside of what we already have. So, I don't know. Why don't we just make it optional? That kind of seems fair.
Make an extra credit.
No extra credit. No. If you want to do it, if you feel like you need to do it, why don't you do that? I can help you with it. But those circuit worksheets are good for Calc because the answer is on the worksheet already, so you'll know if you did it correct or not. And then if you turned it in, I'll give you credit for it. If you don't, I'll excuse you. Let's just do that. Because I forgot to attach it until the middle of the day, so. Okay, section 5. We've already done this. I don't know why it's in here twice. But this has a little bit additional on it, so that's kind of why we're gonna do it. Linear approximation, I believe the first time we did it, I think it was called local linear approximation. It was like unit 2 or something like that. It was a while ago. Do you guys even remember what this topic is? Do you want me to try to draw it out for you? Okay. Maybe I shouldn't have used A. So linear approximation is when you have a function that you know the information about, like the red one, and you're asked to find or to estimate this blue point, which is close to your function. So linear approximation is saying that we can take the slope or the tangent line at a spot close to what you're trying to estimate. I'm going to use this. Sure, that's good enough. So we're going to take the tangent line information at the values that we know to estimate the one that's close. That's what linear approximation was. Is this ringing any bells? Doesn't look like it. You guys look super excited to be back. Okay. Oh, why can't I think of this in my head right now? My brain's not working then either. I know it's written in your packet. Oh, God, these X's. All right, does somebody want to go to page 2 of your packet? Just tell me how they wrote it. Is it L of A? No. Oh, that is it. Oh, I thought it was F of A. Okay, good. This was X minus F of X? X minus A. Okay, the notation is generally the worst part. You don't have to know that notation. Okay, like I could do these problems all day long, and I still don't know this notation. This should look familiar to you, though, correct? Or not? Did we forget everything? Okay. Who should we call on? We should call on somebody. Jesse. You did a good job of trying to avoid eye contact while you're writing stuff. How do we traditionally write the equation of the tangent? With a slope and a point, so how do we write it up? Point slope, yep. What's f prime of it? You remember what the prime stands for? Yes, good. So the equation of the tangent line, a lot of times we write it as y minus y1 equals m times x minus x1. The other form is y equals m times x minus x1 plus y1. So this is the equation of the tangent line. Linear approximation is you using the equation of a tangent line and plugging a value in for x. Okay, I'm gonna have to do much more of this than I was expecting. Okay. Hear me thinking this was like supposed to be a nice easy section. Okay. I did not count on your powers of forgetfulness and blacking things out. I should have known from trait. Okay, the function f is twice differentiable where f of 3 equals -2, f prime of 3 equals 5, and f double prime of 3 equals 1. Write the equation of the tangent line, then use the equation to find the value of f of 3.1. Okay. Jesse, you want to call somebody for me? My roller is, I had to bring it home because we have our family Christmas this weekend. And I had to bring the bingo for the little kids. So I don't have the roller today. Just give a number then. 12, sounds good. That one got ripped off, yeah.
Right.
Okay, do you remember how to write the equation of the tangent line? What two things do you need, which Jesse reminded you about?
Point and slope.
Okay, so we need a point and a slope. This problem does give us all that, but does not give it in a regular way. What's the point, what's the slope?
What's the point be?
3, -2, because that's the f equation. So the regular function is just the point. Okay, the slope? 5. F prime of 3 means the slope at 3 is 5. Okay, so we'll write our tangent line. I'm going to write it with y equals instead of y minus y1. So y equals n, x minus x1, plus y1. Okay? Are we all right with that? We sort of remembering that? Okay? Can you call the next person for me?
9.
Oh, you guys are all just going to numbers. I think 9 is gone.
18.
18. Okay, you ready?
Yeah.
How do I use this equation to estimate that answer?
Can I just plug in 3.1
In place of what?
x?
Yes. So what would I physically write up? What's your rate?
Y is equal to 5 times 3.1 minus 3 minus 2.
Correct. So 0.1 times 5 is 0.5 minus 2, negative 1.5. That's our estimate of the answer at 3.1. Now, the exact answer for 3.1 isn't negative 1.5, but it's close to that because we picked the tangent line, which gives us answers close. You want to call somebody?
25.
Was that a specific somebody or a random one?
That was random.
Oh, okay. Where's 25? Oh, 30. Okay, the desks are way up. Do you remember why they even put that info in there? No. What does second derivative tell us again? That's true. Slope of the slope doesn't really make sense though. What is the slope of the slope? No. Oh, do most of you forget what the slope of the slope is? Really? That's the curvature. This is concave up. Okay, so our graph at 3 is curving upwards. So that tells us this estimate is an underestimate. Because if the real graph is curving upwards, the tangent line will be below it.
So it's concave up because it's positive.
Yeah, a positive second derivative is concave up. It's curving upwards. Maybe I'm going to keep going on this question. The one portion that we didn't do earlier this year is to find the percent error. This is back from Elg 1, Elg 2, basically a bunch of other classes. Do you guys remember how to find percent error? It is on page 1 if you need it. I think it's page 2, I remember. Percent error is on there. Percent error, you find the change divided by the original number. Did you guys forget how to I feel like you guys forgot how to even just start your cars, take showers, how did you survive? How did you survive these 2 weeks? You just laid for 2 weeks. Sat on the phone in front of the TV. Oh, that was my 2 weeks, but I can still think. Okay. To find the percent error, we need to know what the exact answer should have been. Oh, shoot, we can't do that on this one. They didn't give us a function. Never mind, we'll have to do it on a different one. You need to know the exact answer and the approximate answer to be able to find the percent error. We can't do that on this one because of the way the question was set up. They didn't give us a function. Oh, that's a lot of words. Sure. Okay, this one we can do percent error. Okay. We have a function y equals sine of x at pi thirds. We know the ordered pair corresponding to this angle is 1/2 square root of 3/2. That is super misleading. That's the ordered pair on the unit circle. That is not for the function y equals sine of x. That's just telling you how to find the answer for sine of pi thirds. And that's okay, you guys are smarter, you don't need that. I don't want you to think that that's going to be the point for the tangent line. That's why I crossed it out. That's the point on the unit circle, which tells you how to find answers for sine and cosine, but it is nothing about y equals sine of x. Y equals sine of x would have its own points and its own slopes. Where were we at again? Caroline, who are we going with? 15? Oh yeah, very random there. Yeah, which one was 15? Okay.
On the 8, you just have to plug in pi over 3 and the sine of x.
Perfect. If you wanna use that decimal, go for it, I'm not. That's a lot to write. Okay, so what is sine of pi thirds?
3/2.
Perfect. Okay. Do you want somebody else to do the slope info? Okay. Oh, another random guess.
Um, you take the slope of the point.
Do you want some guidance? Yes? Okay. All of our slopes are gonna come from the derivative. So if this is our original function, the derivative would be, so what's the derivative of sine? Cosine, okay? Our slope is going to be the answer when you plug pi thirds into the derivative. So then what would be the cosine of pi thirds? That's why this thing was up there. 1/2, good. Okay, so now we have a point and a slope, so we can write a tangent line. So y equals m x minus x1 plus y1.
So that equation doesn't.
If you want to write y minus y1,
Oh,
you
yeah,
can.
but is it the normal line or
Tangent line. Tangent line has the exact same slope.
yeah, so then.
The normal line would
you
be,
put a prime next to one?
no. No, prime, it means the exact slope at every x value. This is the equation of the flat line at that one spot. Okay, so here's our tangent line, and if I want to find the linear approximation for x equals 1.05, who's going to help me do that? Yeah, just give a number. 27. How do I find the linear approximation at 1.05?
You plug in 1.05 for x.
Good. I am definitely gonna need somebody else to do this one in their calculator. This is what I don't get about linear approximations to me. This topic is supposed to be something for when you don't have a calculator and you don't have a lot of information. But yet AP always uses this topic with information like this that you need a calculator and you could have found the exact answer anyway. I didn't hear that.
0.866.
I need 867?
Yeah.
Okay. So my approximate answer for x at 1.05 is 0.867. Now let's find the percent error. Basically, let's find out how different this is than the exact answer, because this is the approximation. Who's going to help me find the exact answer?
37.
Oh. You know, you guys can just like call them. I mean, you don't have to pretend that that's their number. How do I find the exact answer anyway from the start?
Plug in like 1.05
Sine, correct. The exact answer would be f of 1.05. So the exact answer, which I don't know, what is sine of 1.05 radians? Hopefully your calculator's in radian mode. It's gonna be close to that.
0.867,423.
Son of a gun. Okay, so 0.867423. This one was 0.86.
427.
4266.
This was 4266?
That was 427.
Okay. So we want to find out how far they are apart. And you don't need positives or negatives when you're doing percent error, it's just absolute value. So I just need to know how far apart these two numbers are, and they are apart 4.00, what? 0, 0, what do I got? 1, 2, 3, 4, 5, 0, 4. Divided by the original exact number. Yeah, the percent error is very small. So you'll get a super tiny decimal, and then you have to multiply that by 100 to make it a percent. This is the percent. Perfect. Or did not everybody get that?
I got that.
Okay.
Well, 6, 1, 1,
To find the exact answer at 1.05, could you explain how
So we were trying to estimate an answer on sine of x. That's what this whole top thing was. If we want to find the exact answer, we just plug 1.05 into sine to start with.
So in your calculator, how would you type it out?
Sine of 1.05.
Okay, so.
This number is radians. This is the angle at a radian measure.
That is
Because pi thirds is technically 1.047 radians.
okay, I see.
Okay. How are we, oh, go ahead. Oh, yeah. How are we feeling on this 0 to 5, 0 being not good, 5 being, I feel pretty good about it. How are we feeling on this topic after just a couple examples? Like, are we feeling good enough to let you go work now? Should I do some more? It's just a hard balance of taking up time and giving you time. Anybody have any thoughts? Okay, if you are not feeling very confident on this, I can certainly go through some more of them with you too. But otherwise, I'm okay with you guys going straight to the homework. And the majority of it is going to be relatively quick. The slowest part is your calculator, by far.